So we're taking a look here. We're just focusing on writing our equations for our variables on both sides contextual problems, meaning that you have a single value, a single variable term that you're solving for, but you're setting two different expressions equal to each other. Okay, so that means you have two different people or two different items, maybe it might be stores or it may be companies that are trying to have a value in which that they'll be equal at a certain point. So like for problem number 1, we have two different people who have different bank accounts. Pedro opened his account with $710 in it, and then he's going to continue withdrawing money from the account every single week. He's going to draw the same amount of money, $35 every single week. Maria is also going to open up an account, but she only has $570 in it, but she only is going to withdraw $25 every single week. And we want to know at what week, after how many weeks of them continuously withdrawing money, are they going to have the same amount of money in their account. So essentially what you're looking for, you are trying to identify at what point is Pedro going to be equal to Maria. We want to know at what point is Pedro going to be equal to Maria. So ignore the different information up here. Just focus on one expression at a time. There's all that information. There we go. Okay. Magic carpet. What is the equation going to, or the expression going to be for magic carpet? If magic carpet is $90 for installation and $9 for square yard.
90 plus 9x.
Very good. 90 plus 9x, or whatever variable you decided to use. You just have to make sure that the variable is consistent throughout the rest of the problem. Okay. What about for carpeteria? What is carpeteria's expression going to be? Brooklyn. Well, it has to be the same variable, so whatever variable we chose, yeah, has to be the same variable. Okay, you guys are not in multivariable or double variable solvings yet. That would be systems. Okay, and we'll try to get to that at the end of the year. All right, I'm not going to worry about solving them right now because I want to just make sure that we're getting through the setup of them. What I want you guys to do is problems 3 through 5 on your own. You're just writing the equation, you're not solving. All right, let's go through problem number 3. Who wants to tell me what they wrote as their equation for problem 3? Nick?
40 plus 44b plus 0.06m.
Is there any reason why you have two variables? We're just solving for...
Per mile.
Yeah, so it's $44 for the day, right? We're just going to be renting for the day. So based off of that, what mileage are they going to be the same? So that means that the day charge is going to be the same. Okay? So it should just be 44 plus.
Plus 0.06m.
Good. I want to make sure you guys understand it's not 6M because $44 and 6 cents are two different setups. This is $44. This is what 6 cents looks like. Okay, 0.06M. So those of you who wrote 6M, that would be incorrect. Okay, and it's equal to
35 plus 0.09m.
Good. All right, let's take a look at problem number 4. What is that going to be for problem number 4, Ari? Ari? Okay. Good. 250 plus 15W equals 200 plus 20W. All right, and then our last one. What's our last one going to be set equal? Demi?
I got 250 plus 25x equals 50x.
Okay, good. And again, you might have a different letter that you chose. It's perfectly fine. Okay. Tomorrow you'll have an activity that again is going to go through those most missed questions from yesterday's activity plus some of these ones. Make sure that you are prepared for it.